Programming languages use several programming paradigms, or you can say style of programming, like generic programming, imperative programming, which includes procedural programming, declarative programming, structured programming, which includes block structured and recursive programming, event driven programming, reflective programming, etc. Object oriented programming is another programming paradigm. It comes under the type of imperative programming and structured programming. It is based on the concept of objects. Objects are containers of data and procedures. Data is stored in forms of fields, also known as attributes or properties. Procedures, also known as methods, are used to operate on those data and modify that. Objects can also interact with one another. Object-oriented programming languages are diverse. Some examples are Java, C++, C Sharp, Python, PHP, JavaScript, Ruby, Scala, etc. Whereas Simula is generally accepted as the first language with the primary features of object-oriented programming. Different types of object-oriented programming includes actor-based, class-based, concurrent, prototype-based, etc. But the most popular ones are class-based. Class-based OOP languages supports two main concepts, classes and objects. Classes are the definitions for the data format and available procedures for a given type or class of objects. Objects are instances of classes. Objects sometimes correspond to things found in real world. For example, a graphics program may have objects such as circle, square, triangle, etc. An online shopping system might have objects such as shopping cart, customer, product, etc. All of these objects will contain relevant data and functions to operate on those data. There are also many prototype-based OOP languages present. JavaScript is perhaps the best known prototype-based OOP language. The main difference between class-based and prototype-based approach is for class-based languages, the classes means the definitions for the data format and available procedures are defined beforehand, and the objects are instantiated based on the classes. For example, you may have a class called country which will contain many data fields like population, area, capital, president, etc. and a method called getPopulationDensity which will return population divided by area. And you may instantiate two objects from this class like USA and India. All of these objects will by default have these data fields and methods. You may initialize these field values during creation of the object. For prototype-based languages, objects are the primary entities. No classes even exist. The prototype of an object is just another object to which the object is linked. Every object can have only one prototype link. New objects can be created based on existing objects chosen as their prototype. There are four general principles of object-oriented programming. They are encapsulation, abstraction, inheritance, and polymorphism. Encapsulation is a concept of binding data and functions that manipulate the data together to keep the data hidden from outside access. This is required when you want to hide the internal representation or state of an object and only show the required amount of data, possibly in a different format. Abstraction is a concept of showing only the necessary information required for a process to function, while hiding the internal implementation details. This enables the user to do more complex tasks without understanding or even thinking about all the hidden complex logic. The word polymorphism refers to a situation in which something occurs in several different forms. For example, when you want to communicate using your smartphone, the communication mode can be anything like a call, a text message, a mail, etc. But the main purpose is to communicate. In object-oriented programming, inheritance is the mechanism of retaining similar implementations of an object or a class by another object or class. For example, we have two classes, Audi and BMW. Both of these classes will have data fields like color, length, width, height, etc. Now you have only two classes for two different cars. If you have hundreds or thousands of classes, you will need to rewrite all of these data fields again and again for each class. And it will become worse if you want to change any data field name. Inheritance can easily solve this issue. You need a new class called vehicle, add all of these fields in this vehicle class, then inherit this class whenever you create a new class. All the fields present in the vehicle class will be available to all child classes. There are several advantages of object-oriented programming. Creating objects which refer to any real-world object makes the program structure very clear. It makes the code easier to maintain, modify, and debug. It makes the code reusable as classes and objects can be reused in a different program. It also increases the scalability of the application.